Hey gang, welcome back to Inverted Pursuits Laboratory. This week we're continuing with Project Prater, and we're going to be actually working on the electronics bay this week. Some other parts of the project have had delays with material coming in and actually some tools to make parts. So we're actually going to be going on to just some things I already have most of the parts for to build the electronics bay. So this electronics bay is going to be predominantly 3D printed. I've got my sled here that all of my electronics will mount to, which this is just feels like a massive sled, which it is, and that just means I'm going to have plenty of space to mount everything and not be concerned about spacing. But I've got ample open space on both sides. I've got spots I designed in for mounting my screw switches. So I'll actually be stealing screw switches from my prototype sled of this that was a lot smaller. And you can see there's some differences between this smaller version and the larger version. One big one being the fact that this band that came all the way around no longer does. Instead, I've got a little square puck that I'll be gluing to the inside for my shock cord rail button mount. But some of those things will be waiting until a later video. Because I don't have a lot of the material I need to be doing glue ups simultaneously. I would end up wasting a lot of glue if I went ahead and did the gluing for gluing this switch band onto the coupler itself. So this switch band is also 3D printed just like everything else. It will get glued on there, and then I'll do a fiberglass layer over the outside of it with the same number of layers that I do on the body tube. That way I don't have this weird like necking down right around here. But I'm going to wait to glue that on and do the layups till I have the fiberglass to do it, and just am doing other fiberglass layups because it would be a waste of time and glue to do that now, since I've got a minimum quantity of glue I can mix up at one time. So for now we're going to set that to the side, but let's start looking at how this thing goes together. So I've got two end plates. These things are 3D printed, and I know some of you are probably already thinking, oh my god, how's he going to do that? Like 3D printing won't hold up. Well, I've got these steel straps, and this is kind of the crazy concept I came up with, that I'm going to put a steel strap either side, and I guess I should also put in the caveat, I don't actually know if it's going to work. We'll find out in testing. So when I do my ejection testing, that's when I'll find out. If it doesn't work, I'll replace them with a fiberglass bulkhead that's standard for doing this type of stuff. But I feel like experimenting, so we're gonna experiment. So we want to make sure we get the holes all aligned. So I'm actually going to use my other eye bolt for the moment to help keep the holes aligned, as I kind of just gently tighten that down. Now that is a lock nut we're using, and we'll have to be careful as far as alignment goes because it's not all perfect. There's a little bit of give in some things. And so this is a 3/8 eye bolt, and then I've got 3/8 threaded rod I'm using. I actually do have a difference in that. My threaded rod is 3/8 24, while my eye bolt is 3/8 16. I would have liked for both to have been 3/8, but that just was not an option when I started building. So I'm going to go ahead and put on my, if I could stop that from spinning, that'd be great. Lock nuts on the end of this, and I know I just want them to stick through just a little bit. Got my shirt caught in this, so I want to undo that. So I'm putting it on just enough that the lock nut, this is actually a steel lock nut rather than a nylon lock nut. I'm just trying to make sure that the lock nut engages the top, and I will be using steel lock nuts on both sides. Nice part about steel lock nuts is they're reusable for more than one on-off. I usually try to set one side as permanent with a steel lock nut, and my other side is the one I take on-off. And there we go. So I can get those both on there. And then We'll start with just some basic, put the strapping, or put the rods through here. I will take parts of this back apart, but then my sled will actually mount on here. And I'll actually note that the sled has a little cutout here so that the steel strapping, to help with the steel strapping. So when we bring this all the way down, it's not perfect, it's just really close. It'll sit flush, which it's not wanting to sit flush right now, which is cool. Might want to do this differently. So the steel strapping I bought is actually a washer plate for a U-bolt, and then I drilled the center hole in it myself. I've been kind of doing some of that stuff here and there over the last couple weeks, just to make sure I had it ready to go for whenever I got around to assembly. So some parts of this are custom made, which I'm a pretty big fan of. I'm gonna go ahead and run those through there. And then we're gonna tighten the eye bolt down. I'll see if I can get this to align just ever so. Yep. And that side did it right off the bat. So let me tighten this real quick. I'll show you a bit closer. All right. So what I did was I made it such that the steel strap, or well, the sled actually has a cutout here that the steel strap was able to sit down into, and that gives me a flush seat on all of these parts so that there's no weird torquing as we go through it. And that pretty much will go on there like this. The top side will go on. I did realize about 10 minutes ago that I'm missing one nut from what I want to have. So it'll sit about like that. I don't know if I did not get the spacing right at all. It's actually about there. So sit about there, and what I usually want to do is take a 3/8 24 nut or two and jam nut right here underneath, so that this actually sits up against something solid and I'm not dealing with just floating. So then I'm basically sandwiching this plate, and I'll have another nut set that goes here, so I'm about 4 to 6 nuts short from what I want to be on here. But that's how that looks. You may notice I have the screw hole, or the holes down here, and this one has an 832 T-nut in it, and I'm actually going to put 3 of those around. So what that will actually do is on the upper body tube, and that's, I guess, another weird thing. This is actually the top, even though it looks like the bottom. This is the top of the sled. So on my upper body tube, which I'll spoiler alert for the next video, it's already glued together. Again, I just don't have the fiberglass. When this goes in there, we actually want to retain the coupler to the upper body tube, and these screws are how I'm going to do that. So I'll mark and drill the holes in the body tube at some point, and they'll thread into this. And so these are just recess points that I designed into it. There's a chance I'll need some different screws, but basically I'm going to take these 440 screws and screw directly into my plastic. With them to retain the big old boy, which I'm actually gonna adjust positioning here a bit. So technically I only need one screw to go through this. That's all I need to hold is one screw. But I'd like to have multiple if I can. If it doesn't work out that way, I'm not going to be overly upset. I may have to file down these screws that I'm using to make them clear the outside of the coupler tube. So yeah, that's pretty close. And as we bring the coupler tube over, the coupler is pretty tight as it is. Whoo, that clears right now. So that one clears, and I'm putting the screw at the bottom point, which is the deepest spot in these pockets that I recessed. So there's 3 holes actually in these T-nuts, and I'm basically trying to align one either down or up, and that's the one I'm putting the screw hole, or the screw through. Alright, so there we go. I've got those mounted around. As I mentioned before, this will be my rail button mount. Kind of getting distracted here. It actually already has the external hole in the switch band where it will mount behind. So basically this will mount inside the coupler, this will mount on the outside of the coupler, and this just gives me somewhere where either I can put a T-nut in the back of here, or I'll be able to thread just into this and it'll give me a mounting block. But again, both of those aren't going to be assembled until we're doing layups. And so our next step is we're actually going to steal the switch band, or screw switches out of this previous design. Once I get this sled fully assembled and the eBay completely finished, as well as the lower body tube and upper body tube. Honestly, once I finish the upper body tube, I may start doing this testing. I'm going to be doing an ejection test where basically I'll load charges up on the nose and we will blast the daylights out of it to see if the 3D printed if the 3D printed bulkheads can hold up. Because I'm not going to fly anything till I've tested that it can actually hold up to the environment I want to put it through. Because I'm not asking for a simple environment for this thing to survive. I'm going to be fairly aggressive on these printed parts. I am still planning to fly 3D printed charge wells, and I'll go grab a set of those to show you. These are something you can buy on my website, just 3D printed charge wells. They're 1, 2, 5, and 10 gram charge wells. So I need to double check the math, but if I remember correctly, it's 5 gram charge wells are needed for this. Mount these somewhere up here. Haven't quite figured out where that's going to be yet. It'll probably be something like this, because I'll need to run redundant dual deploy. So I'll have 2. For initial testing, we'll only need 1. And that is how we're going to go about testing that. So what I'm actually going to do to aid myself, so it usually takes a 4 or a 6, number 4 or number 6 screw to mount. Usually about 1/8 inch is needed. Let me make sure this isn't an 8. Yep, it's a 6. Alright. Oh, 1/8 inch is too big. So let's go down to 7/64. Want that, or do I want 3/32? So what I'm doing here is I'm actually comparing the diameter of the shank of the drill bit over my screw, and I'm trying to see how much of the threads I can see around the diameter of the drill to see how much thread engagement I'm going to get. So usually the goal is you want to drill about 75% of the hole out with your drill bit, and then you want the remainder to be, or the bolt's diameter, like outside of the thread pitch diameter, you want 75% of that. And I know there's some number I could go look up, but I can almost always do this by eyeball. I like 7/64 a bit better, but we're going to start with 3/32 just to be safe. I'm actually going to use the smaller diameter one since they're the same. Alright, so now I've got 2 holes in the top of this for mounting my charge well to, and we're going to go ahead and definitely start with the smaller charge well, the 5-gram charge well. And that'll definitely be where I want to start my testing. That way I can mess around and find out if it doesn't really meet my needs. So we're gonna screw this on in here. And getting a thread started in a hole that's a little too small won't be easy, for sure. You don't want it to be easy. If it goes in really easy, that's how you know, and like you know instantly you drilled your hole too big. And put together our electronics bay so we can kind of see how the full assembly looks together. Alright, so that all shifts on there. You can see down it how everything looks inside there. Our switch band will go around the outside, and the switch band will actually get clocked because it's already got 2 holes in it to line up with where my 2 screw switches go. So those actually line up. Oh, that's not the right set. No. Well, they line up really close with that. It's not quite perfect. Not sure which one I'm off with. Doesn't seem quite right somewhere. Okay, not quite sure where the air is. Like, not quite sure at all, but I will get that worked out. It's pretty close to that. So you have the 2 holes that'll go up here for a screw switch and the one in the back for the rail button. The purpose of this is such that when it's sitting on the rail, with this side being the rail button, I've got very easy access to my 2 screw switches for turning on my deploy electronics. But then from there, our bulkhead, last bulkhead goes on here, and then to hold it all together, these are steel lock nuts that I'm not going to tighten because they will make my life a nightmare. That's the electronics bay, and I'll go ahead and put the coupler on here just to show, and the coupler will sit dead center. And then that allows, again, spoiler for the body tube section you've already seen, this whole thing slides right up on in there like that. And if I grab one more body tube section, this will be the top of my lower body tube. Oh, yeah, I'm hitting on bolts down here. That's not surprising. It's because they're not tightened down. Am I hitting on bolts up there? I am. Okay. Well, that answers a question. So, well, that's funny. So a smart thing is to always check everything you're doing. I thought I checked everything in CAD and I made a mistake. So I'm going to show it off because I'm going to have to redo this. So you're looking down there and you can see that my threaded rods with nuts hit on the neck down portion of the body tube. So where it goes from a thicker to a thinner point right here, you can see that these are interfering. It actually means I'm going to need to move these studs in a little bit further. So we'll have to redesign that. Probably what we're going to do to do some testing is we will go ahead and reprint both bulkheads at a closer distance in, and then reprint the sled at a later date because the sled's not necessary for the testing. The bulkheads are really what we're trying to test, and then we'll try to get to that testing as soon as possible. But that's just kind of an interesting mistake that we will remedy in a future video. So for those of you that don't know, Prater is my level 3 Cert project I am working on. To Bob and Jay, if you're watching this, yes, I've got some more work to do because I made a very entertaining mistake. I hope you're enjoying seeing some of this process live. I'm not trying to hide the mistakes I make. I want people to see that I do make mistakes, and I had to rethink my design because I forgot about the fact that that would be an issue as to where the threaded rods get placed. I thought I'd verified all of it in CAD. Obviously, I did not. Thankfully, because of my strapping, I have the ability to move this in because the strapping is slotted. So I've got plenty of room to move it in and get it outside of the interference zone. So we'll do that and show in a future video how all of that goes together. Hopefully at that time we'll be doing the glass work on this and the glass work on the upper body tube. I imagine it will be in the upper body tube video. I've already started filming. You guys will see that, and then we will do ejection testing at that time to verify that the bulkheads do work and that the body can hold up to the forces that I'm wanting to put through it, and that we're not going to have any issues in our design. So thank you all for watching. I hope you've enjoyed learning a little bit more about the process that goes into building a rocket and even some of the pitfalls you will suddenly find along your build path that you did not anticipate. These little pitfalls are some of my favorite things. They're really frustrating. This is incredibly frustrating to find, but it means you're trying and you're learning, and that is the end-all goal of rocketry, is to try and learn and do it in a safe manner. So thanks for watching. I'll see you all in the next video.